So we're taking a look at limiting reactant. There are multiple ways to do this kind of a problem. So we are going to start off with first method, which I like to call mole of reaction. You may also hear me refer to this as a number of recipes. In order to do this, since the goal is to find the limiting reactant itself, what we're going to do is we're going to assess each reactant individually. But what we're going to ask ourselves is essentially how many reactions can we make, is what we're looking at. As we do this, we're going to take our nitrogen, the given amounts of nitrogen, so these are my givens. So I have 2 moles of nitrogen, that's what they gave me. In one reaction, I only have 1 mole of nitrogen. So this is going to give me 2 moles of reaction, or a total of 2 recipes by using my nitrogen. If I was to use my hydrogen, I start off with my given, my 5 moles of hydrogen. So notice in both cases, we are starting with the given, whatever the problem told us we have. Then we are using the stoichiometric ratio. So in this case, we're going to use the 3. So we're going to use whatever number is from the reaction itself. So then here we're using the chemical reaction. Stoichiometry. So then in this case, we'll make 5/3 of a mole reaction, or 1 2/3, or you can plug that into your calculator and you get 1.667 moles of reaction. So since the hydrogen gives us fewer moles of reaction, since I can make less with the hydrogen, that's going to mean that my hydrogen is limiting. So again, the reason I know that is because I did an analysis. I took both reactants and I'm comparing something from both of my reactants. So I took my nitrogen, figured out how many moles of reaction my nitrogen could make. Took my hydrogen, figured out how many moles of reaction the hydrogen could make. And then I'm comparing these 2 numbers. So this is my comparison to figure out how many moles of reaction I can make. And what's going to matter is it's going to matter which one's the least. So this is the comparison I'm making to actually figuring out which one is my limiting reactant. This one is where you look at the amount of product produced. This one can be especially useful when the goal is to figure out how much product you're going to make in the first place. So in this case, what we're going to do is we're going to take the givens that we have and we're going to solve for the amount of ammonia that they would make. So again, I'm going to wind up doing this twice. So I'm going to start with my 2 moles of nitrogen, and then I'm going to use, so this is my given, then I'm going to use my reaction coefficients. So for every 1 mole of nitrogen, I actually get 2 moles of ammonia. So again, I'm pulling that from the reaction coefficients themselves. So that means I can make 4 moles of ammonia if I could completely react all of my nitrogen. But I want to find out what would happen if I could react my 5 moles of hydrogen. So if I take my given moles of hydrogen again, and for every 3 moles of hydrogen, I can get 2 moles of ammonia. What this is going to give me then is 10/3 or 3 1/3 or 3.33 moles of ammonia. So to figuring out which one's limiting reactant, I'm going to compare this stuff over here. So I'm going to compare the amount of ammonia I could make if I could react all of my nitrogen, the amount of ammonia I could make if I could react all of my hydrogen. And what you see is that the smaller number is going to give us our limiting reactant. Because the thing is that I'm going to run out of hydrogen before I could react all of the nitrogen. If we had all the stuff we needed to do all the nitrogen, I'd get 4 moles. If I had all the stuff to react all the hydrogen, I'd only get 3 moles. So this goes back really well to a food analogy where you're like, oh, well, I have a whole loaf of bread and I could make lots of sandwiches, except I don't have very much peanut butter. So the peanut butter is going to be that limiting reactant. So in this case, my hydrogen is going to be my limiting reactant. And what you should notice is that this is identical answer to what we had before. So in the first method, we figured out that hydrogen is limiting, and we're using the same numbers, the different method, and we still have hydrogen being limiting. So everything's turning out just as it should. Now, there's a third method, which this one is also very common. I like to think of this as comparing reactants. So this one, some people have already learned it, and so it makes perfect sense to them. Other times this one can get a little bit hairy. But here's how it works. In all of the reactions, in all the methods before, the goal was to compare things. What we're actually going to do here is we're going to compare the amount that we have to the amount that we would need of each reactant. So we have nitrogen and we have hydrogen. And you'll notice we can actually already start this have column. So we have 2 moles of nitrogen and we have 5 moles of hydrogen. Now to figure out the need column, what we're going to do is we're going to essentially ask ourselves for the nitrogen. If we were going to react 5 moles of hydrogen completely, how much nitrogen would we need? So what we're going to do is take our 5 moles of hydrogen, then we're still going to go from given to the reaction itself. So we have 3 moles of hydrogen used for every 1 mole of nitrogen. So my hydrogens will cancel, and what I will have again is my 5/3 or my 1.667 moles of nitrogen. So this is the amount that's needed. So I can put this in my need column. Now, from this, you can't usually answer the question, because what I've found is that the real question here is then left, do I have what I need? So we said we've got 2 moles of nitrogen. We only need 1.66 moles, which means, yes, we actually have more than we need. That would mean that nitrogen would be our excess reactant. I'm going to say that again. Since what we need of nitrogen is actually less than what we have, that would mean that nitrogen is our excess reactant. Now I'm going to go ahead and finish the table, in part because it'll bother some people if I don't. So in order to figure out the need column for hydrogen, I'm basically going to ask myself the opposite question. This will also show, well, what would have happened if you would have done it the other way. So if we have 2 moles of nitrogen, how many moles of hydrogen would we need to completely react the nitrogen? Now notice, we're starting off with a given amount of nitrogen, so 2 moles of nitrogen. Then I'm going to still use my stoichiometric coefficients. So for every 1 mole of nitrogen, I need 3 moles of hydrogen. So in this case, I need 6 moles of hydrogen. So that would go here. So here's my 6 moles of hydrogen. It's the amount that I need. And then the question is, do I have what I need? No. I have 5 moles of hydrogen, but you're telling me that I actually need 6 in order to completely react all the nitrogen. So no, I do not have enough hydrogen to completely react all the nitrogen. So this is then my limiting reactant. So now you have 3 different methods that you can use to solve for limiting reactant. Which one you choose is completely up to you. Everybody's got their favorite. Frankly, it doesn't matter. They will all get you to the same place. Rather frequently is oftentimes we ask for the amount of product produced. So if you wanted a method that was going to be something we asked you, we always at one point will ask you the amount of product produced. Now the thing is that you still need to be able to do multiple things. And so personally, I like the mole of reaction method because it's actually the fastest method. If you'll notice, all you actually do is you take the given number of moles from the problem and divide it by the stoichiometric coefficient. That's actually all you're doing here. So this one's really pretty quick to do a quick check to figure out which one is your limiting reactant.